What's going on, everybody? Got another video here. This is the area under the curve. So it's first what we're going to do is we're going to approximate the area under the curve, and then we will learn how to find the exact area under the curve. So the first problem that we're going to work is we're going to approximate the area. All right, so it says approximate the area in the first quadrant to the left of the line x equal 4 and under the parabola y equal x squared plus 1. And it tells us to use 4 rectangles. So let's go ahead and take a look at this. So the first thing we want to do is graph it. Let me change colors. So we want to graph this thing. And this is a parabola, vertex at x squared plus 1. And yes, the graph comes this way also, but all we're interested in is this part over here. We're not going to do the area over here. Okay? We're just finding the area underneath the curve in the first quadrant here. And so here's the line x equal 4. And we're going from 0 to 4, and we want to find this area right here. Now, it tells us to use 4 rectangles, so that means we need to split this thing up into 4 rectangles, like so. Okay, so we got 4 rectangles here. Now, what we're going to do is we're going to find the area of each one of these rectangles, and we're going to add them up. Now, I'm going to work this 3 different ways. We're going to work it using left endpoints, right endpoints, and midpoints. All right, so first, let's use left endpoints. So that means we're going to have our points right here, and we're going to draw our rectangles in. All right, and you can see that the area that we're going to actually find is going to be less than what the actual area is. Okay, because you can see these gaps right here. So what we need to do is find the area of each of these rectangles. So what do we need in order to find the area of each rectangle? Well, we need the width of it, and we need the height of it, don't we? All right, so let's find the width, and we'll call that width delta x. That's the width of each rectangle. And the width of each rectangle is going to be the same. We're breaking it up into 4 equal width rectangles. So to find the width of the rectangle, delta x, that is b minus a over n, where this is a and this is b, from your starting point to your end point. And n represents the number of rectangles. This right here is your n. So to find the width of each rectangle, that's going to be 4 minus 0 over 4, which equals 1. Now, they're not all going to turn out this nice where, you get the width of 1. But that's what it is. So here we see delta x is equal to 1. Now let's write it like this. This width here is 1. All right. So that means this x value here is 1. This x value would be 2, and this x value would be 3. Okay, but the width of each one is 1. Now we need the height of each rectangle. Well, what's the height of the rectangle? That's from here to here. What is that height? Well, it's the y value, isn't it? You see that? So what would this y value be right here? Well, it would be, let's do that in a different color. Let's let's see, how about here? This would be y of 1. I'm sorry, not y of 1. This would be y of 0. You see that? So in other words, if we take, see x is 0, so if we take the 0, plug it into here, that would give us a y value of 1. So that's the height of it. Now what about this height? Well, I would plug the 1 into here. So this height right here would be y of 1. This height right here would be y of 2. See, we would plug the 2 in. And then this height right here would be y of 3. So what would the area be? Well, let's see, let's get back to this color. So my area would be the width, which is 1, times the height, which is y of 0, plus the width of this next rectangle, which is 1, times the height, which is y of 1, plus the width of the next rectangle, which is 1, times the height of that rectangle, which would be y of 2, plus the width of the last rectangle times the height, which would be y of 3. And so this would be the area is equal to, now, let me show you something here. I know this is just a 1 right here, but it's not going to always be 1, okay? But, I mean, you can write it like this, but the easy way to do it, see the 1 here? I can factor that 1 out and just write y of 0 plus y of 1 plus y of 2 plus y of 3. All right? And so what I'm doing is I'm taking the width of each rectangle, I'm factoring it out and just putting it here, and I'm just writing it one time. And then I'm summing up the heights. So I'm going to sum up the heights and then multiply times the width. So in the next parts, when I do right endpoints and midpoints, I'll leave this step out and just write the width out here and sum the heights up. And so I get the area is 1 times, now, what do? Well, we take the 0, plug it in here, so 0 squared plus 1 is 1. And then I plug the 1 in, 1 squared is 1, 1 plus 1 is 2. And then plug the 2 in, 2 squared is 4, 4 plus 1 is 5. And then plug the 3 in, 3 squared is 9, 9 plus 1 is 10. And so this area is going to be, let's see, what is that, 18? So there's the area that we get. We get 18 as an answer. All right. All right, so now that's left endpoints. Okay, this is using left endpoints. Now, let me say this. Those of you that are doing your homework and web work, I'm not sure what method they want you to use in web work. I think on some of the problems in web work, they don't actually say. I would maybe start out using left endpoints, and if it tells you that's the wrong answer, then use right endpoints. You're probably not going to use midpoints unless it actually tells you to use midpoints in web work. Okay, so I guess just start off using left endpoints. If that doesn't work, use right endpoints. All right, so now let's work the same problem, but using right endpoints. So in order to do that, to set everything up, delta x is going to be the same. Okay, we'll find delta x just like this, which I'm not going to show the work, but let's go ahead and draw our graph again. We're going from 0 to 4. All right, I've got 1, 2, 3, 4. Delta x, the width of each rectangle, is 1. Okay, Now, so you know how to set all that up. It's just like what we did with left endpoints. All right, so now let's use right endpoints. So to do right endpoints, let's draw in the rectangles. And so I draw my rectangles in. And you can see that the area that we find here is going to actually be more than what the actual area is, because you can see the little pieces of the rectangle sticking above the graph. All right. And once again, this height here would be what? Y of 1. See, to get to this height here, we got to plug 1 in. And let's go ahead and write our function down here. Okay, so we would have to plug 1 into here to get this height. What about this height? We would have to plug in 2. This height, we would have to plug in 3. And this height, we would have to plug in 4. All right. All right, so let's go ahead and find the area. So the area is the width of the rectangle. So remember what we talked about just a while ago. So I'm going to take the width of each rectangle, and that's getting factored out. And then I'm going to sum up the heights. Okay, so that's going to be y of 1 plus y of 2 plus y of 3 plus y of 4. And so the area is equal to 1 times, so I plug the 1 in, that's going to be 2. Plug the 2 in, that's 5. Plug the 3 in, that's 10. And plug the 4 in, that's 16 plus 1 is 17. And so the area is 24. Is that 34? Is the area? Let me make sure. Yes. So we get the area is 34. All right, now there's a big difference, right? There's a big difference in what we got. And that's because, I mean, if you think about it, we're only using 4 rectangles. We could use 8 rectangles, 10 rectangles, 20 rectangles, okay? And the more rectangles you use, the more accurate you're going to be with the area, okay? So keep that in mind. And like I said, this is just approximating the area. All right, so now let's work this problem one more time using midpoints. So let's see what we've got here. Try to make this kind of wide here to give us some room. So there's 0, there's 4, 1. Okay, so there's our 4 rectangles. And what we're using here is midpoints. But let's see, this is 1, 2, 3, and we know the width is 1. Okay, same as the other 2. But in this case, I'm using midpoints. So I'm going to come to the midpoint of the interval. See that? To draw my rectangles. All right. Now, let's look at this. So we need the height of this rectangle. Well, the height of this rectangle, or of each rectangle, is evaluated at the midpoints. You see that? So what's the midpoint of 0 and 1? That would be 1/2. What's the midpoint here? 1 plus 2 is 3. 3 divided by 2 is 3/2. 2 plus 3 is 5. 5 divided by 2 is 5/2. 3 plus 4 is 7. 7 divided by 2 is 7/2. So that's the x values for the midpoints. So we know the heights now. That's going to be y of 1/2. This height is going to be y of 3/2. This height is going to be y of 5/2. and this height is going to be y of 7/2. So our area is going to be 1, which is the width, and then I'm going to sum up the heights. So that's y of 1/2 plus y of 3/2 plus y of 5/2 plus y of 7/2. All right. And so our area is going to be 1 times, now let's write our function down, x squared plus 1. All right, so that's going to be, let's see, we've got 1/4 plus 1, and that is going to be 5/4 when we plug the 1/2 in, and that's going to be 9/4. So yes, I'm putting all this in my calculator. I can do it in my head, but I just want to make sure that I write the right numbers down. That's going to be plus 13/4 plus, and then 25/4. That would be what, 29/4? Let me make sure, or double check myself. Yep, 29/4. And then we've got 49/4. Let's see, 49/4 plus 1. And that would be 53/4. And so our area is, let's see, 5 plus 13 plus 29 plus 53. That is 97/4. So what's that divided by 4? That's actually 24.25. Okay, or you could leave it like that. But that's the area we find using midpoints. So, which one is correct? Well, they're all correct, and I don't think any of them is going to actually give you the exact area. Okay, I know the left and right endpoints, they're going to be way off. The midpoint, it should be a little bit closer to what the actual area is. And actually, we're going to have a problem. We're going to work here in just a minute where we find the area of this problem, the exact area of this problem. And so we will be able to compare it to the two. Okay? We'll be able to compare the areas. All right, so let's come up here. All right, so here we go. We got the area under the curve from A to B. Okay, so that would be like from that 0 to 4, that area. And now the notation that they're using in this section is not actually going to be the notation we're going to use going forward. We have not done the definite integral yet. That's the next video or the next section in the book. So we'll have a little bit different notation of how we write these things. Okay, but for now, we don't know how to do that yet. So this is the notation we're using right now. But this is not the notation you will use going forward. All right. So it says here the area between A and B is capital F of B minus capital F of A, which, writing it out in more detail, the area from A to B is the integral f of x dx, and we're going from A to B, is capital F of B minus capital F of A. So basically what this is doing is it's telling us to integrate the function and then evaluate the antiderivative at A and B and subtract the two. Okay, so let's look at this. Find the area under the curve y equal x squared plus 1 between the y-axis and the line x equal 4. So that's what we just did. That's the problems we just worked. But we're going to use this instead. Okay, so if you look at the at the graph, we're going from 0 to 4. We're looking for this area right here, and we're not using rectangles. So we've got the area from 0 to 4. That is equal to, that's going to be the integral of, well, I tell you what, let's do it like this. Let's write it like this. Let's first integrate x squared plus 1 dx. And that's going to be 1/3 x cubed plus x plus c. All right. Now, let me talk about this for just a second. I'll talk about it again in the next video also, but let me just mention it right here. This plus c right here. So watch what I do. That's going to be the antiderivative evaluated at 4 minus the antiderivative evaluated at 0. That's going to be f of 4 minus f of 0, which that is equal to 1/3 times 4 cubed plus 4 minus, and that's going to be 1/3 times 0 cubed plus 0. Now, this is what I don't know if you've noticed. If you notice this, if you do, that's great. You might be thinking, well, you didn't write the c down. No, I did that arithmetic in my head. Think about it like this. Let's just kind of, don't, if you're taking notes, don't erase what you've got, because I'm going to put it back. We've got the plus c right here, and we've got the plus c. All right, if we brought this plus c down. Well, look at this. What's c minus c? It's 0. The constant term is going to cancel out every time. So there's no sense in putting it, okay? So we just leave it like this. So basically what I did, I said, okay, I've got a plus c here, I've got a plus c here, but they cancel out to 0, so I'm just not going to write them, okay? And so this is going to give us an answer of 76 over 3. And if I put that into my calculator, that gives me 25.33, and the 3's just keep repeating. So there's my answer. So you can see that the left endpoints and the right endpoints, they were way off. I think we got, what, 18 for the left endpoint, 34 for the right endpoints, and then let's see, what did we get? And then we got 24.25. Yeah, we got 24.25 for the midpoints. We got 24.25 for the midpoint. So you can see the midpoint, using the midpoints, that was closer to the actual area. So this right here is the exact area under the curve, okay? This 25.3333. All right. So we just got a couple more. All right, so let's look at this one. Find the area under the curve y equals x cubed, that is between the lines, x equal 1 and x equal 2. All right, so just a quick sketch. So we know this is what the, that's not what the graph looks like. The graph looks like this. All right, and here would be x equal 1, here would be x equal 2, and so this is the area that we're finding. So let's go ahead and integrate this thing, x cubed dx. So that's 1/4 x to the 4th plus c. So my area from 1 to 2 is equal to f of 2 minus f of 1. And so this is going to be 1/4. Now, let me show you something here also. So if you're taking notes, just stop writing right now. All right, so that would be 1/4 times 2 to the 4th minus 1/4 times 1 to the 4th. Okay, and remember, we just don't write the c because they're going to cancel out. Now, you see how I wrote this? And yes, I understand in this problem it's not that big of a deal. But let me show you something that I think makes it easier. Because, if we took this and instead of writing, well, you see how we had that? Let me see if I can undo that. You see how the 1/4, it could actually be factored out? Okay? So look at this. What if I wrote the 1/4, and you see the 1/4 here, and then I wrote the 2 squared minus, 2 to the 4th minus 1 to the 4th. You see that? So if you just have this single term here like this, just leave the 1/4 out here and then just plug in your A and B. It's like you're factoring this number out. Okay? It makes it easier to calculate. Now on this problem, you can't do that because you've got the 2 terms here, so you couldn't just leave the 1/3 outside the parentheses. You have to write it like this. But on this one, when you just got that single term like this, you can leave that coefficient out in front. And so this is what? That's 16 minus 1 is 15. So that's 15 over 4 would be our exact area. All right, last problem. Find the area under the curve y equals 4 minus x squared that lies in the first quadrant. All right, so if we make a quick sketch of this graph, looks like this. And that's the area we're looking for. They want the first quadrant. Okay? So let's integrate this thing. So that's 4 minus x squared dx, which that's 4x minus 1/3 x cubed plus c. And now we want to find our area. Oh, but wait a minute. Look at this. What numbers do we use? In the previous problems, they gave us the x, they gave us a and b, but in this one they don't. Well, we can see we're going to go from 0 to whatever that is. Well, what is that x value? Well, we got to find it. So we've got to take our function here, 4 minus x squared, set it equal to 0. And so that's going to give me 4 equal x squared, x equal plus or minus 2. So this would be your -2, this would be your +2. So you can see I'm going from 0 to 2, 0 to 2. And that's going to be f of 2 minus f of 0. And that's going to be what? 4 times 2 minus 1/3 times 2 cubed minus. Now, let me say something else here. For this one, I'm going to write it down, but then I'm going to erase it to show you this. That would be 4 times 0 minus 1/3 times 0 cubed, right? But look at that. Look. You use your head here. We're plugging 0 in for x. Do you see that when we plug 0 in, that whole thing is 0? You see that? So instead of doing all this, just put -0. And you can put it in brackets if you want, I guess, just to show that you plugged it in and you got 0, that you did it in your head. And so this is going to be 8 minus, what is that? 8 over 3, which that's going to be 16 over 3. And so that would be your area under the curve. All right, and that is all of this video. That's it. I hope you enjoyed it. I hope it helped. And, when you're finding area under the curves, you're not going to do it by using rectangles like the first problem we worked. You're not going to do that. You're going to find areas like what we did on these last 3 problems. You're going to find that exact area. But, you never know. You might have a problem on the test where approximate the area using rectangles. So you need to know how to do that. So I hope this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.